Hello, Algebra 2. In this video, we're going to just do a few review problems for writing equations of lines. So we're graphing before, now we're going to write some equations of lines. We're going to keep it pretty straightforward here. We've got y equals mx plus b, our slope-intercept form, y minus y1 equals m times x minus x1. That's our point-slope form. And then y equals a number is a horizontal line, and x equals number is a vertical line. That's because for y equals a number, you'd have a slope of 0, and that's like y equals mx plus b with the slope of 0, so just y equals b, the y-intercept. X equals a number, vertical line, that's because the x-coordinate of that line is always the same number. The y-coordinate changes, but for a vertical line, the x-coordinate never changes. So for number 1 here, write an equation of the line through 7, negative 2, and 4, 4. So anytime I am going to write the equation of a line, I need the slope. I got to figure out what the slope is, because point-slope form and slope-intercept form and point-slope form both require the slope. And if I have 2 points, I can find the slope. So my first job is going to be, I'm going to find the slope. M equals y2 minus y1, so 4 minus negative 2. I'm going to be careful about my minus negative there. And then 4 minus 7 is x minus x. Got to do the same order that you did from point to point. That would be 6 over negative 3, which is negative 2. So now I have my slope. And the problem could ask you in a couple different ways. It could say, just write the equation. In that case, we're going to use the information we have. We have a point and we have a slope, so I'm going to use point-slope form. So if I wrote it in point-slope, it would look like this. Y, and you can pick either point. I'll pick this first point. Y minus negative 2, because it's y minus y1, so y plus 2 equals m negative 2 times x minus x1, which would be 7. So let's maybe color code this a little bit. Y, the minus 2 is y minus negative 2 becomes plus 2. My slope was 2, and that's the slope there, the slope of negative 2, excuse me. And then my x-coordinate, x minus x1, is at 7 there. Okay, or we could have used the other point. We could say, oops, that's not the pen, or we could do y minus 4 equals negative 2 times x minus 4. Either of those are acceptable. Okay, the question might, though, it might specify, it might say write it in slope-intercept form. And if that's the case, you have to start with point-slope still, because we aren't given a y-intercept. Okay, a y-intercept is always 0, some number, and if you don't have the y-intercept, then we're not going to write slope-intercept form. So we have to start with point-slope and then convert it. So you're going to take either one of those, and let's just use the y minus 4 because it's right there, and you just distribute, and then you add the 4 to the other side. So I'm going to distribute, so we get y minus 4 equals negative 2x plus 8, and then if I add 4 to both sides, I get the y alone, which turns it into slope-intercept form, negative 2x plus 12. Okay, so that's slope-intercept and point-slope. Number 2, write an equation of a line with slope negative 2/5 through the point negative 10, 14. Well, in this one, we already have the slope. So that's a little easier, so we can write an easy point-slope equation. And we would say y minus 14 equals slope negative 2/5 times x minus negative 10, so that'll be plus 10. Okay. If we wanted to convert it to slope-intercept, once again, you just distribute and solve for y. So we would then have y minus 14 equals distribute negative 2/5 x This is going to be minus 2/5 times 10. If we do that, we get, this is just like when we were solving with our fractions equations. Okay, you can divide the 5 and the 10 and get 2. 2 times 2 is 4. And then add the 14, so we'd get y equals negative 2/5 x. That would be plus 10 if I add 14 to both sides. Plus 14, plus 14. Okay. Number 3, remember to pause or rewind if you need to see something again, or catch up your writing. Number 3, write an equation of a vertical line through 6, negative 5. Okay, well, anytime it's that, a vertical or horizontal, I kind of like to draw a little sketch for myself. 6, negative 5. And so then it's vertical, so it's going to look like that. All right, I'm a big fan of having a second point, and that kind of helps me remember what this equation should look like. So I like to write down another point that this vertical line goes through, and an easy one is that x-intercept of 6, 0. And the reason I like this is because then it sort of shows you, hey, look, both of the x's are 6. That's your equation, x equals 6. Okay, so sure, you can memorize a vertical line as x equals a number, x equals 6, but if you find a second point, it'll like scream out at you, oh, the x value is 6, that's the equation I should use. Similarly, for number 4, write an equation of a horizontal line through negative 2, negative 8. Okay, same thing, make a little sketch. Negative 2, negative 8's like down here, and it says horizontal line. And so I could pick another point on that horizontal line, maybe the y-intercept, which would be 0, negative 8. And I'm give that nice big hint there that the y-coordinate on this line is always negative 8. So my equation should be y equals negative 8. Y equals negative 8. All right, to finish up this video, a couple reminders about parallel and perpendicular. So lines are parallel, okay, when they have blank slopes. Well, parallel lines are like headed the same direction. They never intersect, so they have equal slopes. Perpendicular lines, on the other hand, they intersect, but they intersect in a very specific way. They intersect at right angles. You guys did a lot of that in geometry last year. Okay, perpendicular when they have opposite reciprocal slopes. That should be something you've heard of and you remember. So we'll see some questions tomorrow that involve maybe writing equations of parallel lines or perpendicular lines, and so we'll need those facts about opposite, reciprocal, and equal. All right, that's all. Thanks for watching.